Notes 12b. Evaluating functions. Objective. I can evaluate functions. Essential question. How do I evaluate linear, quadratic, and exponential functions? While you're taking notes, be sure to join the Pear Deck, contribute to the slides, watch this video, fill out the foldable, and ask questions when needed. What type of phone do you own? Drag the icon on this slide. Do you have an Android, an iPhone, something else, or do you not have a smartphone? Here's the key vocabulary for you to become familiar with in this section. Evaluate, to find the output given a specified input. Solve, to get a value that satisfies one or more relations. Distribute, to multiply something by a factor. Factor, to undistribute. F of x equals mx plus b. G of x equals a times x minus h squared plus k. And h of x equals a times b to the x power. Those are the three functions that you'll work with most in Algebra 1. Linear, quadratic, and exponential. Linear and quadratic are considered power functions. They have common differences. Exponential functions have common ratios. Another way to look at ordered pairs. So we have x comma y, input, output, domain range, x, f of x. If you're looking at a coordinate plane, if you draw a C, that's the order of the quadrants. 1, 2, 3, 4. And get your coordinate point on there. You always put x first and then y. X is corresponding with how many you go left or right, and then y corresponds with how many you go up or down. For p equals 0, 6, 1, 4, 2, and 6, identify the domain and the range. So remember, domain is the x values, range is the y values. Drag the icons to the correct spots. Order them from least to greatest. We are ordering them in a set. For this one, p equals 0, 6, 1, 4, 2, 6. Evaluate f of 0. So when x equals 0, y equals what number? You drag that icon right here. Same thing here, same thing here. Now let's look at this one. For p equals the same set as before, f of x equals 6, x must equal, there's two numbers there. What are they? Drag the icons onto the correct spots. And then when y equals 4, x is what? Drag the icon. Example 1. For h equals negative 1, 7, 3, 9, 5, 11, 7, 13, and 9, 15, h of 7 is, this is looking for when x is 7. So then y would be 13. Okay, h of negative 1. So we found it right here, so it must be 7. So that's from this one. Okay, h of 9. That's going to be this one right here. So we're going to put 15. Okay, now we're going to find the x values. When h of x equals 11, which is right here, x is 5. When h of x is 7, x is -1. And when h of x is 9, x is 3. For this one, there could possibly be more than one x value. On this one, there's always only going to be one y value, unless it was not a function. The domain, left, right, x, would be -1, 3, 5, 7, and 9. The range, down, up, y, would be 7, 9, 11, 13, and 15. Okay, now you try this. Do this example. Find the values indicated given the table. So like when x is 10, what is the y value? When the y value is 5, what is the x value? Identify the domain, identify the range. Use the example from before to help you. Example 3. Find the values indicated given the graph. So the first thing we want to do is label each of these coordinate points. It doesn't have these numbers specified, so let's just say that each increment is 1. So this point would be 1, 2, 3, -3, 1. And then this point right here would be -1, 1, 2, 3, 4, -4. This point right here would be 0, 1, 2, 3, 4. This point right here would be 1, 2, 3, 3, 0. This one would be 4, 2. And then this point right here would be 5, -1, 2, 3, 4. Okay, so f of -3. When x is -3, y is 1. Okay, f of 3. When x is 3, y is 0. Okay, f of 0. When x is 0, y is 4. When x is -1, y is -4. Okay, now when y equals 2, x equals 4. When y is 0, x is 3. When y is -4, x is both -1 and 5. And then when y is 1, x is -3. So again, you could have two x values going to the same y, but you cannot have two y values going to the same x. So you could have two or more. On those, you can have multiple of those, and you can only have one on these. So the domain is left, right, x. So your domain is -3, -1, 0, 3, 4, and 5. You just order the numbers from least to greatest, the x values. And then the range is down, up, y, f of x. And order those y values from least to greatest. -4, 0, 1, 2, and 4. Notice I didn't write -4 twice, you only have to write it once. Alright, now you try one of these. Identify the 4 points, label them, and then what is f of 2? What is f of 4? What is f of x equals 3? What is x when that happens? And what is x when f of x is equal to negative 2? And then identify the domain and the range. Function machines and function notation. A function can be thought of as a machine that assigns one output to each input. F of x is the function where f is the name of the function. X tells what number to plug into the function. And then the whole thing, f of x, is the output of the function. F is respect to the input is x. F of x, you could just call it y. And then 3x plus 4 is the actual function, the expression here. This is an expression. And this whole thing right here is a type of equation. It's a special equation where x's cannot go to multiple y. One x can't go in multiple y's. Find and illustrate f of 2 and f of negative 1 using the function machines below. So we have a 2 being input here. So somebody typed the 2 into the formula. 3x plus 4. So it's going to be replaced with 3 parentheses 2 plus 4. 3 times 2 is 6. 6 plus 4 is 10. So the output would be 10. So these are the outputs. These are the inputs. If you input a negative 1 into this function, this expression right here, your output would be 1 because 3 times negative 1 plus 4 would give you 1. Okay, now you do this one. Draw the slides. So you're given 3 different functions here, a quadratic, a linear, and an exponential. And negative 1 is done for you. And then now you have to plug in for negative 2 and for negative 3 on just the linear one. So where these blanks are, replace it with the input number. And then g of negative 3, write out the whole entire process. You don't have to evaluate these, just set them up. On the next slide, we have f of x equals 4x plus 2. So f of 10 equals 4 times something plus 2. Drag the icons for the number that should go in here. And then drag the icons on what the answer should be. Example 5. Find the range of the function for the given domain. A. F of x equals negative 1/2 x squared plus 5. The domain is negative 1, 0, 2.5. So to find these, you want to evaluate this expression at each of these points. So we're going to find f of negative 1, f of 0, and f of 2.5. And from there, you can just use a calculator to type in just the expression part. Don't type in the f of x equals part. So let's go ahead and type this in for the first one. So we have negative 1/2 times, well, to get the fraction, you could do control divide on the TI Inspire. So then we have 1/2 parentheses -1 squared, which could be caret 2. Caret is just the little upside down V button. And then plus 5. And then enter. So you have 9/2. And then that's the same thing as 4.5. Okay, let's do the next one. Instead of typing the whole thing again, you just press up to highlight your previous expression and press enter. And then now what we have to do is change the -1 to 0. Press enter, you get 5. And then we'll change it again for 2.5. So go up, highlight, enter, change the 0 to 2.5. And then enter. So you have 1.875. Okay, so now you try this one. Find the range of f of x equals 2x squared minus 1 for domain -1, 0, and 1. So when you're working these out, you want to again find f of -1, f of 0, and f of 1. Find those three things. What are they? Example 6. Find the domain of the function for the given range. So we have g of x equals x minus 5, and then the range is -4 to 3.5. So with g of x equals -4, x equals what? When g of x equals 2, x equals what numbers? And then you do the same thing for the last one. We could use a table. We could solve these. We could also solve for x. So let's go ahead and graph this on Desmos. So we'll put g of x equals x minus 5. So from here, let's go ahead and type in our numbers. G of x equals -4. And we're going to see where it intersects our graph. It's at x equals 1. If we zoom out, notice that it only goes through in that one spot. That is always going to be true for linears, but it can pass twice for quadratics. So x would be 1 for this one. Okay, let's do it again, except for now instead of g of x equal -4, let's say it's equal to 2. Okay, so let's go ahead and find where they intersect. It's at 7, 2, so x would equal 7 here. And then let's change this to 3.5. See where it intersects? 8.5. So these would be your values for the domain. Okay, now you try this one. Find the domain of f of x equals 2x minus 4 for the range -4 to 6. So you're going to find these numbers. So on Desmos, you want to graph this function and then find the intersections for each of these. Let's look at this example. Alex has $200 in his savings account. If every month he deposits $25, write an equation that models this situation. So is this discrete or continuous? This would be discrete. He deposits exactly $25 each month. It's not a continuous thing there. It's 25 and then nothing, 25 and then nothing. It's monthly. How long would it take him to save $300? So what you would do is write this equation to model the situation. So they have $200 at the beginning. So you can say that's your B value. He deposits $25. We're going to call that the M value, the slope. So we got y equals 25x plus 200. So 300 equals 25 times something plus 200. Well, if you take away 200 from 300, you have 100 equals 25x. Divide by 25. It would be 4 months. How much will he have after 6 months? So for this one we're solving. For this one we're going to evaluate. So we have y equals 25 times 6 plus 200. So that's going to be 150 plus 200. That's 350. So $350 after 6 months. Now, an important thing to know when you're evaluating expressions is that parentheses matter. When we type this in the calculator, -9 squared minus 3, well, it's going to be 81 minus 3, that's 78. But now, -9 squared minus 3, if you put that in, that would be -81 minus 3. And that would give you -84. 78 is not equal to -84. So those parentheses mattered there. -1 squared minus 3. We have 1 minus 3. That's -2. Okay, -1 squared minus 3. -1 minus 3. -4. -2 doesn't equal -4. Parentheses matter. If you were to write this as a function and you're finding f of -9, it would be x squared minus 3. This one, it would be negative x squared minus 3. So again, when you're evaluating these expressions, always put those parentheses. It might not always give you different answers, but it will in some situations like these right here where you have negative numbers. So how do you feel about this topic? Can you explain it to others? Do you know it? Is it becoming more and more familiar, or you're not sure where to start yet? Drag the icon on how you feel about it. And then on the last slide, describe in your own words how to plug in an expression into a function. Be sure to include and emphasize the need for parentheses when plugging these in.